Welcome to this presentation where we will show you the COR and COR Synergy, Swegon's revolutionary new system, presenting opportunities and providing a unique product which not only offers many benefits and cost savings, but also addresses the latest environmental issues. This presentation will begin with an overview of why this product has been developed, discussing its application and comparing it with others, giving some details on how it works, whilst also discussing key strengths and how it brings all the different products from Swegon into one complete system. We will also touch on sustainability and will give you an overall feeling of how the system can best be adapted to different applications. And finally, we will summarise with the main technical features. Developing the COR and COR Synergy derived from changes to legislation and looking at the other systems in the market and seeing how Swegon could improve on these, taking the best features from each system and putting them into one system, these systems being VRF and traditional chilled water systems. Around the world are a variety of climate change targets, different countries producing different variances on the same legislation, with the main target being to reduce energy and carbon emission, whether being by the Energy Performance of Building Directive F-gas, the Kigali Agreement or the ERP Directive. Many countries are offering carbon tax incentive schemes to encourage the reduction of energy emissions, to contain the global temperature increase to below 0.5 Celsius by the end of the century. All countries will gradually phase down HFCs by more than 80% over the next 30 years and replace them with more environmentally friendly alternatives. A specified group of developed countries have already begun the phase down. Several developing countries will freeze HFC consumption levels in 2024, followed by additional countries in 2028. Achieving these targets means there must be changes to existing systems. So, let's consider the systems that are most common out there. VRF systems. Over the last decade, we have seen that more and more consultants and businesses have tended to use VRF systems due to the simple design, attractive appearance, simple control, easy and cost-effective installation, and high efficiency due to the direct expansion and the heat recovery offered in 3-pipe systems. The simplicity of designing VRV systems also saves time and reduces exposure of the design. The downside is poor temperature control and drafts, and with recent legislation, global warming and new refrigerants, pressure is being put on the use of these systems due to the refrigerant volumes, refrigerants within the building, and additional costs of leak detection systems. The alternative we all know is the traditional chilled water cooling and heating systems, which offer the benefits of closer control, no refrigerants within the building, but the downside is they are complex, being made up from several components from different suppliers, all put together by the main contractor, who is then responsible for making it all work, unlike VRF systems, where one supplier, whether it be Daikin, Mitsubishi or Samsung, supplies all the indoor units, outdoor units and controls. The overall costs on small to medium-sized buildings are higher. So what's the alternative? Swegon's new COR Energy system, a system that combines the best of VRF and traditional chilled water systems, offering simultaneous heating and cooling, reduced refrigerants volumes, no refrigerant within the building, reduced carbon emissions, lower installation and material costs, and free hot water, along with many more benefits which are listed, and we will discuss in a little more depth. So what is COR Synergy? It's a combination of different products from Swegon, using the Omicron multifunctional heat pumps, the Tetris Rev-TB heat pumps for boosting hot water, terminal units and the COR complete with backnet protocol, making one complete system. Before we go into details of the components making up COR Synergy, let's see a quick flow diagram of the system working. Hot and chilled water is produced by the multifunctional Omicron chiller, which via 4 pipes distributes the water to the COR, which then via 2 pipes either sends chilled or hot water to the terminal units, which then heats or cools the air. At the heart of the system is the patented COR. We will now go deeper into its structure, operation and controls. The COR is a hydraulic changeover box which converts a 4-pipe chilled and hot water system into a 2-pipe system. Providing all the controls to give simultaneous heating and cooling based on demand, whilst also saving the client installation and material costs, offering flexibility and space savings, along with many more benefits. The COR is made up of a metal casing housing all the components. To the COR you have hot and cold water flow and return connections, so 4 pipes. From the COR to the terminal units you have just 2 pipes, a flow and return. This can be either hot or cold water dependent on demand. Within the COR you have a series of 6 port valves and flow sensors, all connected via a number of manifolds, bleed valves to remove excess air, and an access panel which doubles up as a ventilation panel. All the valves are wired to a control panel, housing a programmable LCD controller. All components within the COR are insulated to prevent condensation forming, but the bottom access panel doubles as a condensate drain pan. The operation of the COR is quite simple. Fitted on all terminal units and fan coils is a controller supplied by Swegon. This controller takes a signal from a remote controller or remote sensor based on set temperature. The terminal or fan coil controller then sends this signal to the main controller in the COR. 0 to 3.7 volts for cooling, 3.7 to 7.2 volts for deadband, and 7.2 to 10 volts for heating. Dependent on the room requirement, this then tells the valve in the COR to send either hot water, nothing, or cold water to the fan coil unit. Based on the voltage sent to the valve, the flow is adjusted by the flow sensor. The flow can be set for each valve based on the capacity of each terminal unit or fan coil, which is normally set up during commissioning. All this is done through a simple comms network. Taking a closer look at the valves, there are 6 port valves, 1 for each outlet, each fitted with a flow control sensor, which can be set based on the capacity and flow rate required for each fan coil. The valves are available in 2 sizes, 15mm and 20mm, giving a capacity range of 1 kW to 12 kW, dependent on the size and voltage signal. Each actuator is wired to the COR programmable LCD controller. There is 1 actuator per valve. This rotates the valve 90°, allowing either hot water or cold water to flow to the terminal and fan coil unit. The actuator is connected directly to the flow sensor, which then regulate the water flow to the fan coil based on the commissioning setting and the demand from the space. Communication between the valves and the main COR controller is done via Modbus. The data and settings for the valves can be set within the factory or on site via a smartphone or laptop. The control of the COR is via an LCD programmable controller. All the valves are pre-wired to the controller within the COR, simplifying the amount of on-site wiring. The wiring is further simplified by a quick daisy chain, twist pair between each fan coil and terminal unit, and Cat 5 or 6 between the COR boxes, allowing quick and easy installation with huge cost savings. All external communication is via BACnet protocol. You can have up to 16 units controlled via 1 box, although more than 1 unit off each port becomes a master-slave type arrangement. You can connect 30 boxes together through the BACnet protocol, so in effect, on one system, you can have 16 by 30, which equals 486 units. The main controller has an LCD screen, so you can set up and monitor each box while on site or remotely if you choose to. The COR is available in various configurations. There are 3 sizes available from 23 to 45 kilowatts in capacity. You have a choice of 4 or 6 ports, with each port being able to range in capacity from 1 to 12 kilowatts. The COR is available in horizontal or vertical format, ideal for false floors, ceiling or hotel risers, and you can also choose between left or right-hand connections to suit all applications. The COR is unique, having many strengths over alternative systems. Traditionally, as a water-based system, you would be offering 2 or 4 pipe options. The 2-pipe system has the benefits of additional surface area on the fan coils, giving greater efficiency, but only cooling or heating, not offering simultaneous cooling and heating or heat recovery. To provide simultaneous heating and cooling, you would offer the Omicron multifunction units, which has a chilled and hot water circuits, but that comes at a price with an additional water circuit and complex controls. It adds to the overall installation time and costs. But with the addition of the core, you now benefit from the greater heat exchanger surface area, as you're using 2-pipe fan coils, so the heating and cooling output is greater in the same size units, but gaining simultaneous heating and cooling and heat recovery, whilst reducing the additional pipework and gaining up to 20% in energy saving. From the photos, you can see the 2 different fan coil unit installations. The first is the 4-pipe being complex and messy, but with the use of the core, site work is reduced. There are less joints and no valves on the fan coil as seen in the second photo. The units take up less space, maintenance is external to the space, and for exposed installation it is a much neater solution. All that supported by a 30% installation cost saving over a traditional 4-pipe system. The simple installation not only saves on material costs but also labour, with plastic-type pipe being able to be used from the core to the terminal units, and the daisy chain wiring makes the whole system complete and easy to install. Flexibility has been designed into the core, featuring an L-shaped condensate drain pan, allowing the core to be installed horizontally or vertically, ideal for hotel riser cupboards, false floors or ceiling, or even exposed ceilings. Maintenance is far simpler, as all the controls and main components can be installed in an accessible area when no one is working. The valves are all in one location rather than on the units, and with the core having a quick access panel for general setup and a drain pan which is totally removable, making access to all components easy, should the need arise. The Swegon product range is extensive, and using the core brings all the other products together in one complete system, COR Synergy. Traditionally, a contractor would purchase individual components from various suppliers, put them all together and try to make them communicate and work, which created its own problems. COR Synergy is a complete system with all products being able to be supplied by Swegon. Looking at the individual items that make up COR Synergy, they each have their own features and benefits, which we can now look at in a little more depth. Providing the hot and cold water simultaneously is the Omicron multifunction chiller via 4 pipes. This supplies the core with hot and cold water, which via 2 pipes supplies the terminal units, whether that be fan coil units or chilled beams. The cold RX and HC supplies tempered air to the fan coils or chilled beams. And finally the Tetris Rev TB, which boosts the hot water for domestic use. First is new Omicron, now featuring a great range from 40 to 850 kilowatts with 25 models. Available in different configurations for high efficiency and low noise compliance, with integral inverter pumps and controls, a smart defrost system, which provides heat recovery and simultaneous heating and cooling across the whole building. Let's take a closer look at the operation of the Omicron multifunction unit. The circuit diagrams show the cooling operation, 2 circuits and 4 stages of cooling. As the cooling demand increases, the number of compressors running increases, producing chilled water, while the hot air is rejected by the condenser fans to atmosphere, giving an EER of approximately 3.5. In the heating operation, the same happens in reverse, with compressors loading subject to demand to 100%, where the COP is around 2.9. The defrost is activated on 1 circuit only, and the condenser fans run in reverse, blowing the water off the condenser coils, aiding defrost. Once 1 circuit is defrosted, then the other is activated. Defrost cannot occur on both circuits at the same time, ensuring hot water production is continuous. The Omicron is also able to operate in heat recover mode, producing hot and cold water simultaneously. In normal cooling mode, the energy removed from the cooling circuit is rejected to the atmosphere. In heat recovery mode, this energy is recovered by a heat exchanger. The condenser fans stop running, saving further energy, and hot water is produced free of charge. In heat recovery mode, the total energy ratio becomes the sum of the EER and the COP, and can be as high as 8. For example, for every 1 kilowatt input, you receive 8 kilowatts output. The Omicron is available with various pump options on both cooling and heating circuits. Single or run and standby pumps can be included, both of which are installed within the Omicron. Pump control options then starts with the VP, which adds an inverter for setting up a fixed flow rate on the primary side. VD is an additional module which varies the flow rate based on water pressure drop, the secondary side being controlled by the BMS. VPS having additional controls gives variable flow, based on demand based on the water temperature. The VFPP provides automatic regulations of the primary pumps, adjusting the flow based on the thermal load and pressure differential. In all cases, the secondary pump is controlled by the BMS. Let's take a look at the VPS system in operation. Starting with a load of 100%, all terminal units are providing maximum cooling or heating. The primary and secondary pumps run at full speed, and the Omicron runs at full load. As the terminal units meet their demand, their valves start to close. The flow rate through them reduces and the return water temperature drops, reducing the compressors and the speed of the pumps. As this sequence continues, the compressors offload further, the pumps reduce the flow, until such time there are no terminal units requiring any cooling. The compressors are switched off and the bypass valve opens on the primary side to provide a minimum flow through the chiller. This arrangement is the same for heating. The BMS controls the flow of the secondary pumps. New to the range is a variant on the Tetris W range, the TB. It is exclusive for heating and has been developed to boost the hot water up to 80 C, ideal for raising the water temperature off the Omicron for hot water usage in office and hotel applications. Available in 6 sizes and ranging from 70 to 520 kilowatts, utilising R134A and multiple scroll compressors, it offers a wide operating range, high level of redundancy, and the normal exceptional reliability. It is available with various options, including low noise, advanced control, and Bluethink Swegon's web-based monitoring system. Terminal units are available in various formats: cassettes, wall-mounted, ducted, floor-standing and chilled beams, with the system also able to control small air handling units. All fan coils require only 1x2 pipe coil, so they benefit from greater heating capacities over a normal 4-pipe unit. There are also specific ranges designed for hotel applications, which included the Smart Hotel Solutions, where all access is only required from the front of the unit, avoiding the need for accessing hatches and return air grills. The one-way blow cassette also feature access from below, and being only 135 mm high, it is perfect for small bulkheads or false ceiling, and feature EC low-noise fans. These units are perfect for hotel bedrooms. All fan terminal units are 2 pipes only, providing smaller and quieter solutions, with greater outputs and efficiencies. There is no limit to the type or fan coils that you can use with COR Synergy. Apart from the chilled beams Easy Air, which is able to supply fan coil units from Venticlima, Samsung, Artesai and Panasonic, but other brands can be used, provided they have EC fans with the correct built-in drivers. For standard fan coil control, each fan coil is fitted with an EZ440R4230 controller. The room control is via a remote control EZNS T100 or a remote state. No other types of controllers can be used with this arrangement. When using the Samsung fan coil controller, all Easy fan coils are compatible. Fitted to each fan coil is the FCU F00N and FCU F10N boards. These will then communicate with any NASA Samsung controller that can be simplified, touch, centralized or BMS type. The Samsung controller incorporates a pre-assembled control box, housing the PCB boards with inputs and outputs for various functions. Some fan coils, though, may not be able to incorporate the controller in the fan coil housing. When using Samsung fan coils, all is required is the addition of an FCU F10N board installed in the core. No additional component or site work is then required, and all Samsung NASA controllers and BMS systems can be used. Terminal units come in the range of chilled beams, ideal for hotel and office applications. Available in cassette or ducted type format, offering silent operation and a high level of comfort. The units are available up to 3.4 kilowatts on cooling and 4.6 for heating, offering low height, low maintenance, and the fresh air being supplied via the Gold RX HC. The Cold RX and HC provides the tempered fresh air to the system. This range of packaged heat pumps come in modular format with a compact footprint and feature the latest technology including inverter compressors, EC fans, high-efficiency, sorption thermal wheels and a patented defrost system, ensuring no cold drafts. Starting at 290 cubic meters per hour and increasing to nearly 47,000, this plug-and-play solution is the perfect fresh air system. The sustainability of any product is high on everyone's agenda, and Swegon, having recognised this, commissioned Cundall's UK to carry out an independent study of two systems. The study compared the COR Synergy to traditional VRF systems. The COR Synergy was compared against VRF with a gas-fired boiler and VRF with a high-temperature air-sourced heat pump. The sustainability chapter is a summary of Cundall's UK analysis, and the full report is available upon request. There are currently two critical reasons why boilers and VRF systems are coming under scrutiny. The first is the trend towards decarbonising the electric grid, which has posed an opportunity for efficient electric heat pumps to become a sensible alternative to traditional boiler. The expected further decarbonisation of the grid will bring further CO2 emission reductions. The second is the use of refrigerants being restricted, and those that pose a higher risk to the environment are being phased out. For most refrigerants, GWP and flammability are inversely related. Lowering the GWP means that the substance is less stable. This brings the necessity for careful design of fire compartmentation on buildings where low GWP refrigerants are passing through. These two critical factors, together with the flexibility to connect to future district energy network, makes water-based systems, such as the COR, more convenient. This case study compares the energy consumption and associated carbon emissions of the COR Synergy system with traditional refrigerant-based VRF systems. In order to compare the COR Synergy, an 8-storey C1 hotel that provides 170 bedrooms has been used. The hotel is located in central London with the main facades oriented to the east and west. Here you can see an image of the hotel with the typical floor layout and the assumed thermal insulation standards that the building has been designed. In order to account for the expected life cycle of a future plant, a future CIBSE weather file has been used. This corresponds to the predicted weather conditions in 2050 for the 50% percentile emissions scenario. As a reference, I have shown some of the design data that has been used to select the space cooling, heating and domestic hot water. The COR Synergy VRF with boiler and VRF with ASHP have been applied to the hotel building model in order to give you a better understanding of which products would be best suited to this type of application, and to show their performance in each category. The categories compared are Building Regulations Part L, London Plans Section 5.2, and BREEAM point scoring. Under the 2013 Building Regulations, all developments should demonstrate compliance with Part L. Part L Criterion 1 states that the calculated CO2 building emission rate must not be greater than the target emission rate, which is determined through the National Calculation Methodology. New building regulations will come into force in 2020, and one of the expected updates will be to the carbon emission factors, but for now we have based this on the current SAP 2012 figures. The results show that the VRF with gas boiler case passes building regulations just marginally with a 0.4% improvement against the TER. The VRF with ASHP passes with 16%, and the COR Synergy case passes Part L with a 25% improvement against TER. When we look at this in more detail, we can find that DHW emissions are 44% lower for the COR. The heating emissions are 16% lower, and the cooling emissions are 22% lower when compared to the VRF with a boiler. The Greater London Authority London Plan 2016 and the GLA's Energy Assessments Guidance October 2018 document are the benchmark for the London Planning Regulation. The London Plan sets out a number of core policies for major developments with regards to reducing CO2 emissions and providing energy in a sustainable manner. Non-residential developments must achieve a 35% improvement over the 2013 Part L building regulations. Policy 5.2, minimising carbon dioxide emissions. Policy 5.6, decentralising energy. Policy 5.7, renewable energy. Critically, Policy 5.7 requires that developments seek to reduce their emissions by at least 20% using renewable energy. The carbon emissions from the VRF with boiler system are 10% below the TER for the development. This is worse than the minimum target of 35% for the London Plan. Based on the carbon offset for 2020 of £95 a tonne, the development would need to pay £225,648 to offset their regulated carbon emissions for 30 years. The carbon emissions for the COR Synergy are 64% below the TER. This is better than the minimum target of 35%. No offset payment would be expected for this development. BREEAM is a sustainability assessment method that is used to master plan projects, infrastructure and buildings. BREEAM sets the standards for the environmental performance of buildings through design, specification, construction and operation phases, and can be applied to new developments or refurbishment schemes. It focuses on sustainable value across a range of categories, and the credits are found to be relevant to the COR Synergy. ENE 01 achieves 4 points because the use of heat pump technology with COP reduces primary energy consumption, well below that of gas-fired systems. ENE 04 Part 3. Low and zero carbon initiatives are implemented to reduce emissions. Heat pumps used for the supply of heating or domestic hot water achieve points, which is why the COR Synergy will achieve the available credit. POL 01 Part 1 rewards projects for reducing refrigerant emissions. A central chiller solution such as the COR has a better ability to incorporate refrigerant leak detection and pump down in comparison to VRF. It is also a factory-fitted option, so far more cost-effective way of achieving 1 credit. Additional credits will soon be available. POL 02 Part 1. This rewards heating and hot water plant, which has a NOx emission value below 100 mg per kilowatt-hour. This leans in favour of the COR Synergy because systems that are electrically driven achieve maximum points, whereas systems with boilers depend on the boiler specification. Following the simulation of both the COR Synergy and the VRF systems, the results show that the COR system provides a 26% saving compared to the VRF system for this case study. This table summarises the results for both systems. The savings are achieved through 2 key differences: inclusion of part of the DHW energy within the central heating and cooling system enables heat recovery from the building's cooling load to supply a portion of the building's DHW demand. It also tends to achieve higher efficiencies in operation compared to the VRF system in this comparison case. In summary, the COR Synergy is a compelling solution to dramatically improve the energy efficiency and sustainability of hotel solutions. With the implementation of SAP 10 from SAP 2012 and the update to the refrigerants planned by Swegon for 2021, there will be further improvements to both Part L and BREEAM. Beyond this assessment, following this analysis, the COR Synergy efficiency could be improved further by programming the production of DHW during periods of high cooling load in order to utilise higher efficiencies resulting from the COR energy system working in heat recover mode. The results also highlighted the importance of correctly sizing the buffer vessel linked to the COR Synergy system in order to maximise the overall efficiency of the system. The operating efficiency of the COR Synergy system and the VRF system at nominal capacity are similar, but the COR performs significantly better and part load and heat recovery mode compared to the VRF system. We hope this presentation has been a useful insight to Swegon's COR and COR Synergy product and system. So to recap and summarise on the main technical features. The COR changes a 4-pipe system to 2-pipe system with up to 30% cost saving on material and labour over a traditional system. Simplifies the supply and installation whilst offering flexible and simple maintenance, and providing advanced control and enhanced comfort conditions. COR Synergy provides simultaneous heating and cooling with the byproduct of free hot water, alleviating the requirement for gas boilers and providing high energy cost saving in addition to no refrigerant within the building, reducing the CO2 emissions level and aiding the reduction in global warming. We believe COR Synergy, with the huge cost savings over traditional systems, reduce refrigerant over VRV, benefits of free hot water, is an alternative that will also compete with VRV systems. The advantages and benefits are endless. We will be happy to discuss all these with you or take your questions. Thank you for listening, and we hope you found it as interesting and exciting as we do. Should you have any questions, we would be pleased to answer them. Should you prefer, you can see our question and answers page on our website, or send an email to cor@easyairconditioning.com and we will be pleased to respond to you.